It's really fascinating when you start thinking about those huge scientific projects, the really ambitious ones, like, say, the Gaia mission.
Hmm.
You sent over some great material looking at why they even happen, how these massive projects, big science, connects back to the economy.
Yeah, that's the core question, isn't it?
So for this deep dive, that's our mission, really, to understand the forces driving the funding. What's the thinking behind it? And, what kind of returns are we actually looking at beyond just the pure science, which is amazing, of course, but
Exactly. And that source you mentioned, the Perryman PDF on Gaia, it gives a really useful perspective here, focusing specifically on the economic arguments. They seem pretty central when you're talking about funding high-tech stuff like Gaia.
right. And that's what we want to sort of unpack for everyone listening. Think of it as a shortcut, maybe,
Yeah.
getting to grips with how science, tech, politics, money, how it all weaves together,
Yeah, getting those aha moments without drowning in jargon.
hopefully. Okay, so let's start right there. The big question. Why do we fund these massive science projects? What's the justification?
Well, the source lays out, I think it's eight main arguments that usually come up for investing heavily in space missions.
Okay.
The first one's the obvious one. Scientific advancement. Just that basic human curiosity, wanting to explore, to understand.
Sure, the pure discovery aspect.
But it go way beyond that. The source mentions unexpected spin-offs.
Ah, right. The things you just couldn't predict.
Yeah,
Technologies popping up from seemingly abstract work.
precisely. And then there are the more deliberate ones, the applied spin-offs, where you actively try to take the new knowledge and, make something practical out of it, technology transfer, that kind of thing.
Okay, so the planned and the unplanned benefits. What else?
Well, a huge one is just the technology development itself. To actually do these missions, you often have to invent completely new stuff. You're pushing the edge of what's possible.
Yeah, you can see that. Building the tech is a major undertaking.
And that ties into industrial interest. Lots of companies, different sectors, they get involved in building these things, developing the capabilities. It's big business.
Mm-hmm. And I suppose there's a political angle, too.
Definitely. The source calls it political demonstration, showing off your country's or maybe a group of countries' technical skill. Plus, it can be a great way to get nations working together. International cooperation.
Okay, so prestige and collaboration. Makes sense.
Then there's the societal and cultural impact.
Mm.
Space just grabs people, doesn't it?
It really does.
It gets the public interested, fosters a kind of scientific culture, and it's huge for inspiring kids, getting them into science and engineering, STEM fields.
Yeah, the inspiration factor is definitely powerful. Okay, what's the last one?
And this is the one we're really zeroing in on today. The economic benefits.
Right.
The idea that all this tech development sparks innovation elsewhere, drives growth, creates new markets, maybe even gives access to new resources down the line.
Okay, so that's the list. Science, spin-offs, tech, industry, politics, society, inspiration, and the economy. Now, you said the source emphasizes the economics.
Yeah, this is where it gets interesting, like you said. The author points out that while scientists, naturally, are often driven by the thrill of discovery, the
Mhm.
quest for knowledge itself,
Mm.
when it comes to getting the actual funding, convincing politicians, convincing taxpayers who foot the bill, it's often those economic arguments that carry the most weight.
Ah, okay. So the pure science is the why for the researchers,
Hmm.
but the what's in it for us financially is maybe the key driver for the decision makers.
That seems to be the suggestion. It's perhaps a more compelling case when budgets are tight. You need to show some kind of tangible return.
Which kind of leads us nicely into thinking about space itself, not just as a place for exploration, but as a resource.
Exactly. It's become absolutely essential, hasn't it? We almost don't notice it anymore.
Like what specific?
Well, telecoms, obviously. Satellite navigation, GPS, Galileo, everyone uses that constantly.
Hmm.
Environmental monitoring, understanding climate change,
Weather forecast.
weather forecasting, yeah. Managing crises like natural disasters, and of course, science itself, all depend heavily on having assets in space.
And because it's so critical, you get governments and private companies putting serious money in.
Big time. The source throws out some numbers. Back in 2013, around when Gaia launched, global spending on space was about N200 billion.
200 billion.
Wow. And the U.S. government alone contributed something like $40 billion of that.
Okay.
But then, jump ahead to 2020, the estimate for the whole space economy was up to $385 billion.
That's a huge jump.
And commercial revenues were the biggest chunk of that, over $310 billion. It's really taken off.
And what about Europe's role in this?
Also significant, in 2013, the European space sector had sales around N5.5 billion, covering civil and military stuff, and employed about 33,000 people.
So a major industry.
Absolutely. And you saw big investments across the board. Japan, China, France, Germany, Italy, India, the EU itself, all spending over $1 billion on space back in 2013.
So with all that money flowing in, people must be trying to figure out if it's actually worth it, economically speaking.
Oh, definitely. There's been work on this going back decades, actually, since the 60s in Europe. Governments commissioning studies, often getting industry involved to try and measure the economic impact.
Like trying to track those spin-offs you mentioned.
Exactly. The source mentions a specific group, BETA, at the University of Strasbourg. They tried to quantify those indirect industrial benefits from European Space Agency, ESA projects.
To basically prove the value of the public funding.
That was the idea, yeah, to provide some concrete numbers.
And was it just them or others too?
The OECD, the Organization for Economic Cooperation and Development, they've done similar analyses, trying to figure out the return on investment across Europe. You know, for every euro or pound put in, what do you get back out?
Did they find anything interesting? Any numbers?
They did, for 2009, though the source adds a note of caution. Interpreting these figures precisely is tough.
Okay, noted. But what did they suggest?
Well, for instance, Norway apparently saw a return of about 4.7 for every 1 million NOK invested. Denmark, around 3.7 million turnover for every 1 million DKK put into ESA.
So multipliers, essentially.
Yeah. The UK's space industry had a value-added multiplier around 1.9. U.S. commercial space transport claimed nearly 5 times return. NASA apparently even claimed a 7-to-1 return at one point.
7-to-1, that sounds high.
It does. And again, the source stresses these figures need careful interpretation. Measuring all the effects, direct and indirect, is really complex. It's hard to pin down causality perfectly.
Sure, I get that.
Yeah.
But the general direction seems positive.
That's the takeaway, I think. While the exact numbers might be debated, the overall trend in these studies supports the idea that investing in space does bring economic benefits alongside the other impacts we talked about.
Okay, so that leads to a more fundamental point, maybe. What is the connection between doing really basic blue sky science and boosting the economy overall?
Right. How does discovering, say, a new fundamental particle eventually lead to economic growth?
Yeah, the source makes a distinction here, doesn't it?
Yeah.
Basic versus applied research.
It does. It references the OECD's definitions, actually. Basic research is about acquiring new knowledge, understanding the fundamentals, with no specific application necessarily in mind. It's curiosity-driven.
Just figuring out how things work.
Exactly. Whereas applied research is taking that knowledge, or existing knowledge, and aiming for a specific practical outcome, solving a particular problem, developing a specific product.
So how do we get from A to B? From the basic stuff to economic prosperity?
Well, the source brings in a quote from Peter Gruss, who used to head the Max Planck Society. He argued back in 2012 that something like 80%, a huge chunk of economic growth in industrialized countries, actually comes from new technologies. And crucially, he said it's basic research that provides the vital foundational ideas for those new technologies.
So basic research is like the seed corn for future tech.
That's the argument. And it's interesting because older economic theories didn't always emphasize this link so strongly, but newer theories, often called endogenous growth theories.
Endogenous, meaning from within.
Exactly. These theories propose that technological progress isn't just some random external factor. It actually comes from the accumulation of knowledge within the economy itself.
Ah, I see. So investing in knowledge creation, like basic research, directly fuels growth according to these models.
That's the core idea. It suggests basic research isn't just a side benefit. It's potentially a fundamental driver, maybe even essential for continued growth. It highlights our own ability to generate and use new knowledge as the engine of prosperity.
But is there a clear formula? Like spend X on basic research, get Y in GDP growth?
Well, the source points out it's not that simple. There's no universally agreed calculation.
Right.
And you can kind of see that reflected in how different countries were spending on space R&D back in 2013. The percentages of G&T varied quite a bit.
What were some examples?
Let's see. The UK was around $12 per capita, 0.03% of GNP. Germany was higher, $19 per capita, 0.04%. Italy, similar, $17, 0.05%. France, significantly more, $44 per capita, 0.10%. And the U.S. way out ahead, $150 per capita, 0.32% of GNP.
Wow, big differences. So no clear consensus on the right amount to spend, maybe reflecting that uncertainty about the exact link to growth.
It seems that way, although the underlying idea that basic research is vital for creating wealth and advancing society that was kind of embedded in things like the EU's Lisbon strategy back in the
What
2000s.
was that about?
It was this big push to make Europe a more competitive, knowledge-based economy. It didn't necessarily mandate specific research funding levels everywhere, but it implicitly recognized that investing in knowledge, including basic research, was crucial.
Okay, so the link between research funding and growth seems plausible, maybe even strongly suggested by the
Hmm.
evidence. But the precise mechanics aren't fully mapped out, which raises a tricky question for funders, doesn't it?
What's that?
Well, does it make sense to demand that every single basic research project demonstrate a clear, immediate, calculable economic return before you fund it?
Yeah, that's a great point. The source seems to suggest that demanding that might actually be counterproductive,
Oh, so?
because it could end up stifling the very kind of exploratory fundamental research that doesn't have an obvious application yet, but might lead to the biggest breakthroughs down the road. You risk killing the golden goose, maybe?
Which brings us right back to Gaia as a case study.
Exactly. It started small, didn't it? Just an idea between two scientists in Leiden back in '93.
Just two people talking.
Yeah, but then look at its development. Thousands of people involved, scientists, engineers, managers across industries all over Europe. A massive technical undertaking.
And now it's flying, collecting data.
And hundreds of scientists are still working on that data, including, importantly, lots of early career researchers, PhD students, postdocs.
Right, trading the next generation.
Exactly. And these people gain incredible skills, and then they move on. Some stay in academic science, but many go into industry, into education, management roles, taking that expertise with them. That's another kind of impact.
So the author of this piece we read, they suspect Gaia is actually providing significant economic returns, even if this specific paper doesn't have the hard numbers to prove it for Gaia itself.
That's the strong suspicion, yes, that alongside the absolutely groundbreaking science, there are these wider economic benefits flowing from it.
And this wasn't just a theoretical exercise for the author, right? They were involved in related discussions.
That's right. The source mentions this work fed into a 2014 study by the European Academy's Science Advisory Council, ESX. They were looking at the whole question of human versus robotic space exploration.
So these debates about value, cost, return, they're happening at very high levels, influencing actual strategy.
Absolutely. It shows how interconnected these scientific, economic, and policy questions really are.
Okay, so as we sort of wrap up this deep dive based on your sources,
Yeah.
what really stands out is this incredibly complex mix.
Yeah.
You've got pure scientific curiosity, that drive to know. You've got the push for new technology. You have political goals, national prestige, collaboration, and then underpinning so much of the justification, especially politically, these economic arguments, they all swirl together to make something like Gaia happen.
So that sums it up pretty well. And while nailing down the exact economic return for every euro or dollar spent on science is, well, really difficult.
Yeah.
The overall evidence we looked at strongly suggests the space sector does create substantial economic value. And maybe more fundamentally, that basic research, even when its path to application isn't clear, really is crucial for long-term growth and innovation. It's the foundation.
Which leaves us with a final thought, maybe something for listeners to chew on. Given that we do get these incredible scientific leaps from missions like Gaia, and there are these compelling arguments, even if not perfectly quantified, for economic and societal upsides,
Right.
how should we as societies balance that potential against the undeniable risks and the, let's face it, enormous costs?
That's the perennial question, isn't it?
Yeah. And are purely financial metrics enough? What other ways might we need to think about measuring the true value, the long-term value of these kinds of grand scientific adventures? Something to ponder.
Definitely food for thought.
Thanks for joining us on this deep dive.